Hello everyone! Today we have a video explaining something. Well, I guess we sort of explain stuff all the time. But today we're going to explain why RAII. And yes, I used why rather than what is because of the rhyming factor. So let's read about it. And if we do that, we can see that, well, this is tiny. So let's zoom in and read the first sentence. Resource allocation is initialization. There we go. That's what RAII is. But what on earth does that mean? Well, if we, I should have left it big here. If we scroll down, they have this this wonderful example here that doesn't really tell me a whole lot. And you might be going, yes, that's why I'm watching this video, because the documentation is a little bit confusing on what RAII is and why would you want to use it. So let's get into it. As you know, when you're working with C++, there basically are two main types of variables. There's things that you create on the stack, so stack variable, and there are things that you create on the free store, or in C it's called the heap. And you would have something like new int 123 like this. And this obviously looks a lot easier than this. And the other thing is, if we say we want a new integer, when we're done with it, we need to remember to delete it. This is where RAII comes into play. The stack variable, when it goes out of scope at the end of its scope, in this case the main function, it goes away. It's gone. It's great. The free store variable, however, though, or I might use the word heap because it's easier to say and it's shorter, but when you create something on the heap, it is saying I need a memory space the size of an integer, and I'm going to create a pointer to that space in the memory, and I want to store this number into it. And when you're done with it, you need to tell the OS, oh, by the way, I'm done with that memory location. If you don't, it's called a memory leak, because if you do it enough, especially with large classes, it will seem like the memory is leaking out of your computer. And you might go, well, this is easy enough. I create it and then I remember to delete it. But that's the problem, remembering to delete it. So RAII is a fancy little mechanism where we basically can work with the heap, but almost use it like it's the stack. And the reason for that is we quite simply just tie the two together. So let's see an example, because examples clarify everything. Let's create a class. Call it RAII. I'm going to make it public right away, which means we could have used a struct just as easily, but I think class carries a certain connotation of what we're aiming for in this situation. And let's put in here our pointer to somewhere, we'll call it the heap. Somewhere on the heap. Well, now when we initialize our RAII, we're going to say that we want, let's say we want an integer. And we'll call this input. And to keep things simple, we'll initialize it right away. We'll say that our, our heap here is going to be a new integer that holds our input. And for our destructor, we are going to say that we want to delete our heap variable. Now, if you're wondering about this initialization stuff, I plan on making a video on that, because other languages don't do it this way. If you're coming from a really high level language, all of this heap stuff would have went inside of the curly braces. So I'm going to explain in a different video why we do it this way in C++. However, back to the topic on hand. Now, instead of saying I have a pointer to this free store and we need to create it, and then after that remember to delete it, Now we quite simply can just say RAII, my, I'll say variable, is 1, 2, 3. So what we have here now is my variable is an instance of the RAII class. It is an object. 1, 2, 3 is stored into the heap. Once this object goes out of scope, so right here, when it goes out of scope, it will destruct. And when it's destructing, it will automatically clean up all of the pointers. In this case, there's only one of them. And it does all that automatically for us. So there you go. That's RAII. It's as simple as that. Now you might be wondering, wait, if it's that much more complicated to use stuff out on the heap or the free store, why would we do that in the first place? And I'll answer that question real quickly because that's a very valid question. If you can do stuff on the stack, why would you do stuff in the free store when you want to tie it to the stack? Because the stack is easier and it's simple. In the case of this is really overkill. An integer on an x86 system should hold approximately 4 bytes, which is not a whole lot of memory. But let's say you have, I don't know, let's say you have some sort of file reading class and you're pulling in a 2 gigabyte file of data. It's filling your memory up, it's caching everything. It's the most amazing class you've ever created in your life. Only problem is, if you create that on the stack, you're going to get a Stack Overflow error, which is the same name as that wonderful website that has a lot of people helping out others. So check out Stack Overflow. However, that error that it's named after is a real thing. On Windows, I believe, don't quote me on it, but I think the stack's only like 1 megabyte. So if you try to create a 1 gigabyte variable out on the stack, it's definitely going to overflow. I know that for a fact. It might be 1 megabyte, it might be 10 megabytes. I don't think it's 100, but even if it was, if you try to put a gigabyte on there, you're going to overflow. It's just too big. However, the free store is basically all of the available memory on your computer at that time. So when you say, I want to create a new spot out in memory and I want 2 gigabytes worth or whatever, it can go, okay, I gave you a spot that's 2 gigabytes and you can use it. And that's the main reason why we use the free store, is it allows us to work with really large memory locations and not fill our stack up with a bunch of stuff. Ultimately, it becomes a judgment call. Like strings, I'd probably put those on the stack. Arrays, if I know it's always going to be small, that vector's probably going to end up on a stack. Things like that. If it might become ginormous, then I need to remember that I probably want to put it on the heap. So there you go. That's where RAII comes into play. There are times where you want to use the heap or the free store over the stack. And you want the convenience that the stack provides with taking care of the memory management for you. RAII comes to your rescue. So I hope you found this video educational, entertaining, and I hope you learned something from it. If you did, please subscribe, please like it, and we look forward to seeing you in the next video that deals with random features.